Okay, let's get started. Thank you everyone for coming. For those of you just coming into the room, we're just getting started. Please grab a seat. I will say ahead of time, I can see none of you. So I'm gonna try and keep eye contact with a blob of darkness. I hope that works out. Thank you very much for coming to the talk. I assume you've had a heavy lunch and it's sitting heavily on you after the meal. So I figured we should pick a light topic to go along with it, and therefore we're going to be talking about technical debt. Now, let's start with a bit of audience participation. Please raise your hand and keep it up if you have technical debt in your organization. Now I'm going to pretend that I can see a few hands going up, but I have no idea what's going on, so I'm going to pretend that I can see you. Please keep your hand up if deadlines were missed in your organization because of technical debt. Okay, as far as I can tell, no one took their hand down. Good. Please keep it up for one more second, one more question. Please keep it up if you feel your technical debt is out of control in your organization. Okay, so there's still a fair few hands up. You can put them down now. I'm going to pretend that I saw you and declare that we are all roughly in agreement that technical debt is a problem, and for a lot of us, it's a catastrophic problem within our organization. And that should come as no news to you. So today, we're going to be talking about technical debt, what it is, why we collectively kind of suck at dealing with it, and what we can possibly do about it at the organizational level. So, as with every discussion of a topic we all know and love, we need to start with a bit of definitions, linguistics, so we're all on the same page. What is technical debt? Technical debt fundamentally is two things. It's technical and it's debt. It's technical because it is a deliberate decision made by one or more of the engineers in your company. That's what makes it technical. It is owned by R&D. Right? And it is deliberate because it is the result of a choice you made. Now, you might not have deliberately wanted to create technical debt, but the choice that created the technical debt for you was a deliberate one. And the other part of the equation is debt. So what makes technical debt debt? As with any other kind of debt, it is debt because it accrues interest. If you leave it lying around for long enough, the pile is going to get bigger. There's going to be rats coming in, and you're going to get typhoid. You don't want that. So by definition, a decision made by an engineer that accrues debt over time. It's worth also talking about what technical debt is not. So technical debt is not a one-off hacky script. The fact that the script is hacky, that you don't care for how it was programmed, doesn't matter because it's a one-off. There is no length of time for it to slowly gather up negative effects in your organization. Technical debt is not yucky code, right? It's not code I don't like, so long as that code is factored properly within the rest of the system. And by factored properly, I mean it's well encapsulated, right? If it's behind a consistent, coherent API, then it's not technical debt, generally speaking, because it doesn't accrue interest. It has no opportunity to evolve the damage that it's causing your organization. And a bad technical decision is not necessarily technical debt, right? The fact that I don't like whatever, my build system is Maven instead of Gradle or any other such decision, it's not inherently representative of technical debt. It might have just been a bad decision, but the ramifications of it may or may not lead to technical debt. The debt metaphor is a very, very useful one, right? Technical debt is usually contrasted with financial debt, which is something that we all know and love. You take out a mortgage, you take out a loan, you owe your bank money, you're in debt. But critically, one of the things that I always find a little bit confusing about how people perceive technical debt is, by definition, people perceive technical debt as a bad thing. And that is also true of financial debt. A lot of people perceive being in debt financially as a very, very bad thing. And I kind of get where they're coming from, but debt is not inherently bad. There are a lot of situations, especially in finance, but also in software, where taking on debt is a conscious, deliberate, and totally sensible proposition. So if we take just 3 kind of canonical examples from the financial world, we might have taking on debt so that I can have startup capital. I'm starting a business, I need to hire an office, I need to buy equipment, I need to pay people, all of these things. I need some kind of, a large stack of cash to build on. So I take on debt so that I can start my business, right? And that's a perfectly logical thing to do. Now, in our world of software, one analogy for that could be I assume technical debt. I may make decisions that I know are problematic and are going to hurt me long term so that I can get my product out the door faster, because time to market sometimes really, really wins, right? So the point here is that assuming debt, right, taking on debt is not an inherently bad decision, and having debt is not an inherently bad situation to be in. But there are some downsides to technical debt, as is obvious. So, what does interest look like when it comes to technical debt? Feel free to shout out ideas. What is interest when it comes to these types of debts? Security vulnerabilities is a good one. Yeah, any other ideas? Regressions. Anything else? All right, so either you're still off because of lunch, or you didn't really think it through, because you have all experienced one or more, probably all, of these ramifications. And this is not a comprehensive list. So another example would be flaky tests, right? We made some bad decisions about how we built up our tests way back when, and now our tests are unreliable. That's a common thing to experience. You have system instability. You have what I call abstraction leakage, which is what happens when you have an abstraction in your system that is subpar, that is not up to the task of what you want it to do, but you're in a rush. So you build on top of it anyway, and you hack around things. And that way you take on debt in the form of abstraction leakage that you will later have to clean up. There's also a whole lot of different things that can happen when technical debt is left aside to rot. So these are all examples of what interest is in the sort of technical debt metaphor. But if you take all of these, fundamentally what it is that technical debt, the damage that we assume from unmanaged technical debt is drag. Okay, organizational drag. We want to move forward, we want to deliver more products, we want to improve stability, we want to reduce costs, whatever it is we're trying to accomplish as an organization, technical debt slows us down, or makes it harder, or makes it, in some cases, impossible to make progress in the directions that we want. So that's drag. That's the real villain in our story. Now, it is worth taking a moment to break down the life cycle of technical debt, because the ramifications of it, the methodologies for dealing with it, and the pain that is caused by it looks very, very different depending on where you are in the timeline. So we have a graph here. It's obviously completely made up. Don't take it too seriously, but it is representative of the sort of effects that you're going to be seeing over time because of technical debt. And the proxy metric for this is drag, how slow you get, how many problems you have when you're trying to make progress. So you start with a decision, right? We said technical debt starts with a technical decision. And then you have a nice chunk of time where nothing is particularly bad, right? You know you have technical debt, you've assumed it, it's well understood by everybody, everybody's expecting the ramifications, no one is surprised, no one feels any particular pain. I like to call this the greenfield phase. And then you have another chunk of time where people start feeling the pain. Now, people here is overloaded, right? Because who feels the pain? In most cases, in this phase, the people that feel the pain are engineers, right? If you're working on a product, you have to work around something, or you have to wait for a build server, you have to wait for tests to pass, you have to rerun things because they're flaky. That's pain. So this is the chunk of time I like to call the growth phase. Things are still largely bearable, but they're not fun. You can actually feel the pain. And then what happens after that, if technical debt continues to accrue interest and is left unattended, is organizational panic. And this is the point where things start to really break down in the organization and management starts to take notice because things are that bad, right? You have slipped schedules, you have broken releases, you have unhappy customers, whatever it is for your organization, you don't want to be in this situation. Now you might wonder, what happens if you still leave your technical debt unattended? What happens after management takes notice and starts panicking? Well, there's a word for what happens if you don't pay your debts over a long period of time, and we call it bankruptcy. Now, in financial terms, a bankruptcy is a very simple thing. Your organization is dead. The surprising thing about this is when your organization dies, so does all of your technical debt. So that's one way of getting rid of it, but obviously that is a catastrophic outcome that no one wants. But there is another kind of bankruptcy that fits the bill for our kind of mental model of debt as a technical thing that we need to manage, which is declaring bankruptcy as a choice. And one of the ways you can declare bankruptcy without killing off the company is saying, okay, this product of ours, the old legacy product, is still making money, but the costs of having it around are too high, or the complexities caused by having it around are just too high. We're going to shut it down. We're going to kill off this product and eliminate a whole bunch of technical debt. And as with any such decision, there are also ramifications. You lose money, you lose clients, you lose trust, right? There are costs associated with it. So in all cases, this is catastrophic. This is not a situation you ever want to find yourself in. Being in a panic state is bad enough. Being at a point where you're not sure if you're going to survive the catastrophe is obviously pretty terrible. So, why is managing technical debt so hard? Because we all have technical debts. As far as I can tell, all hands were up for the first question. We all have it. The vast majority of us feel that we're not managing it particularly well. A good chunk of us feel like it's out of control. Why? How do we get here? What makes this a uniquely difficult thing to manage in the software industry? Well, there's a few reasons for it. So first of all, it's impossible to measure. Now, I will qualify that. It might not be impossible to measure, but don't ask me. I'm not a scientist. I'm not an academic. What we do know is we don't know how to measure it. And the corollary of that is, what is the opposite of technical debt? High quality, right? Well-factored code bases with no technical debt. But we don't have a good measure for quality either. So if you're in, as all of us are nowadays, in a data-driven organization, it's really difficult to come up with metrics to quantify technical debt, which means it's very hard to have a coherent conversation about it, especially with management. Next, by definition, technical debt becomes a problem the longer you leave it around. The longer you leave it around, meaning more time has passed since a decision was made, that means that the people that made the decision, the staff that have the context for why the decision was made and how to address it later on in the timeline have very likely moved on, right? If it's been 5 years since you made the technical decision, it is incredibly unlikely that you still have any, really, but more than a handful in all cases of people who are familiar with why the decision was made the way it was, because they've moved on. They've moved up in the company, they've moved to other teams, they might have left the company. So you're missing a lot of domain expertise on where the technical debt actually is and how to manage it. There's ambiguous ownership for the very same reason, which is to say you have a system in kind of a stable state, but that has a lot of technical baggage behind it. In a lot of cases, it enters what's oftentimes called the KTLO phase, the keeping the lights on phase. Right? You have some team somewhere that has a legacy product kind of thrown on them. It's okay, we're not evolving this product, there's not going to be any more releases, you just need to keep the lights on. Right? Has anyone here been in that position? I can't see anything. So hopefully a few of you this resonates with. The ownership of where the technical debt actually resides over time becomes ambiguous. It's unclear who has to deal with that technical debt, and technical debt has a pernicious quality of also expanding beyond the boundaries of the system it originated in. Last but not least, and by far the worst issue here, is misaligned incentives. And I want to focus on that for a good chunk of time. What do I mean when I say misaligned incentives? The incentive structure in your organization is built in a particular way, and ironically, most organizations end up thinking about the relative priorities of their teams in sort of the same way. And that also depends on the life cycle. So when the company or the project are new, when you're in the greenfield phase, the only thing anyone cares about is delivery. Because at that point, there is no traffic, there are no customers, at least for that particular system, right? There's nothing to do other than finish delivering the system. So the only thing you care about is delivery. Then you hit sort of the growth phase, right? You iterate on the system, you add features, you improve performance, you improve stability, you provide and deliver more and more value to whomever your customers end up being. So at that point, the things you care about generally are stability of the things already delivered as a distant second, but also delivery of new features, new products, new everything. And then you hit the KTLO phase, the phase at which no one really wants to mess with the system, but it's still making money, so you just kind of keep it there so that it makes more and more money for the organization. At that point, the things you generally care about are, again, stability, because you don't want to have to deal with the ramifications of a broken system. Cost gets added into the mix, because if you have a system that's making money but is not being actively evolved, then the one thing you could do is optimize your spend, right? Increase your margins as a business. So you care about cost, but you also care about delivery, just not of this particular system or this particular product. You care about other deliveries within your organization. So the recurring theme here is delivery. Delivery is paramount. That is the one thing that every organization at every level, at every life cycle phase actually cares about. Now, you may notice that nowhere on this list do we have things like technical debt or code quality or code hygiene or any word you'd care to mention that has to do with us doing our work better, or at least not accruing difficulties and challenges on the way. So if code quality, hygiene, managing technical debt is not a value, the only time at which it enters into the conversation is when it compromises one of the other desirable deliverables in the company. So the question is, what does it compromise, right? When and what gets screwed over because of unmanaged technical debt? Now, with a greenfield project, not much is happening, right? Again, it's a new thing. There's not much technical debt. There's not much drag by definition. Nothing can get compromised by technical debt in the abstract. In the growth phase, you're starting to feel some pain, because you're iterating on the system, you want to improve on it, and at that point, you're starting to hit whatever it is that your pre-existing technical debt makes harder for you. But it's generally speaking a pretty manageable and small amount of pain, and the people that feel the pain are generally us in the trenches, not the product team, not management, and at that point, not the customers. At the KTLO phase, this is where you actually start feeling the pain. If you have a system with a large amount of technical debt that was left to languish, it's going to hurt you at that phase in everything that you do. It's going to hurt you because you may want to free up your staff for other deliverables, right? You may want to free up the people managing and keeping the lights on this system for other projects, other products, other ways of making money. But technical debt also can have a knock-on and very, very negative effect on system stability, which translates to how happy your pre-existing customers remain and are. And it can also have very negative effects on cost, right? You might have a system that, because of technical debt, is several times more expensive to run, or that can blow out of proportion cost-wise if you're not careful about what you do on AWS, or any of these things, right? So this is where the damage is really starting to be felt. Now, at that point, at the point where you have a large amount of technical debt and you are feeling the pain, and it has been a fairly long while since you made the decision that started off this whole process, you will note that, generally speaking, when management notices, the point where management goes, what is going on here? Why are we delayed? Why are we missing deadlines? Why are we not delivering promised features to customers? Why are we having all of these midnight incidents that mean our engineers can't work on anything else for hours or for days, right? At that point, the organization, generally speaking, is at peak crunch time, right? Because management feels the pain when things slip, which means at this point, the damage is already done. At this point, you have, say, a new version that is supposed to be coming out, and it's not coming out because you haven't addressed some element of it. So at that point, everyone is panicking, right? Management is calling in middle managers to figure out what's going on, and it's always, even if the conversations are very positive, right? I'm not saying you can freely assume everyone involved in this story is well-meaning, well-intentioned, and hardworking. So when upper management calls in middle management, who call in the developers and asking them honestly, like, why did it go wrong? What can we do better? What can we as management do to help? What kind of resources do you need? Those are honest conversations, but at this point, you've already hit peak crunch time and everyone is panicking. And at that point, there's a few other statements you can make, which is that the pain is relegated to the least known parts of your system, because by definition, the thing that hurts you is the decision made the longest ago that has the greatest ramifications because of accrued debt, right? So the pain is in the least well understood part of the system, where the staff that could best deal with that is either long gone, right? They might have left the company, they might just have left the domain and no longer be able to actually apply whatever it is, whatever knowledge is needed to sort out the debt. And everyone else is kind of burned out because they've been firefighting for God knows how long up until that point. So at this point, you're kind of in the least good position to deal with the technical debt that caused your problem in the first place. So if we look at the problem from an organizational standpoint, right? We have a system, the system is broken in some way, it is affecting other deliveries, there is a lot of pain, and we want to solve it, right? If you have a problem, you need a problem solver. The problem solver has to, the skills and the attributes of your problem solvers have to match what the problem actually requires. Now, at this point, having accrued all of that technical debt, our problem is generally complex, right? The complexity can be horizontal in the sense of the technical debt might be in the integration of a lot of disparate systems, and the integration itself is the technical debt, or it can be vertical, as in you have a system, it's been running fine, but it's, it has an old schema, a messy schema potentially, an indexing structure doesn't make any sense. You have one vertical system in your organization that just blew out because of increased scale, because of increased load, because of any of those things. Whatever it is, the problem is complex and it is large in scope. It is also typically highly integrated for the reasons we just outlined. And one other attribute of the pain that you're feeling is that solving that pain is very unglamorous work. Okay, very, very few engineers in my experience are happy to be working on these types of problems, are happy to figure out a legacy system and plan a migration process for getting rid of it and leading that process and following up with the rest of the organization and being held to account for getting rid of the technical debt that other parts of the organization have accrued, right? So the work itself is kind of thankless, which means, on the right side, the attributes of your problem solvers are that they need to be highly skilled because the problems are at this point very, very hard. They need to be available for an extended length of time because if the problem is big, it's going to take a while to sort through it. It's not a one-off, right? It's not a, hey, senior engineer, join that team, help them solve the bug and move on. It's going to be, hey, senior engineer, go plan on how to deal with that and we'll see you in about 3 months, ideally. Because the problems are big and highly integrated and generally involve a lot of different parts of the organization, the problem solvers also need to have the organizational knowledge and clout to actually be able to, and authority in some cases, to actually be able to approach all those disparate teams within the organization and go, hey, we collectively have this problem. I'm charged with dealing with this problem. Here's what I need for you to do. Because if you don't have the organizational clout, the other teams are going to look at you and go, I don't have time for this. This isn't in my priorities. I have a version to deliver. Go away. Right? So you need to be in a position where you can actually involve yourself in the prioritization of other teams and force them to collaborate, or not force necessarily, but convince pleasantly them to collaborate with you on solving whatever problem it is you're trying to solve. And the last bit is, because this work is so unglamorous, because no one ever gets put on stage in the middle of a large company all hands and everyone congratulates them for deleting this system from 7 years ago that no one in the organization actually cares about, right? You need people who are either willing to do the work despite the fact that it's kind of thankless and not very visible, or that are utterly egoless, right? That don't care about the fact that this work is not glamorous and no one particularly cares about it. So, to recap, we need people who have skill, have clout, have availability, and have no ego. Now, you might already be spotting the problem here. And if you do spot the problem here, please shout it out now. No theories? Come again? These people don't exist. Why do they not exist? One iteration into this. These people do not exist because the skills on the left and the skills on the right are invariably in conflict. Your most senior engineers are the people who have the organizational knowledge and clout, and because they're your most senior engineers, typically also are the small group of people who have the skills to deal with a problem that at this point has grown to a huge amount of complexity and baggage. These people are busy, right? You don't have senior engineers waiting around to do something, for days on end. They're not available. They're involved in other projects, in future-facing projects, and whatever it is that your company is trying to achieve in order to make more money in the future. And there is, shall we say, a strong correlation between seniority and ego. Okay? It's not a necessary correlation. There's no causation there. But people who have the skill and have the clout but have no ego are extremely unusual. And even if they exist, you shouldn't depend on their existence in your organization. Because I don't know how many people you know like that. I know very, very few, and I wouldn't depend on being able to hire them. Right? So these people do not exist, and that is one of the major reasons why we're finding it so hard to deal with technical debt when it gets this bad. So, in summary, up until this point, you hit a point where there is organizational pain. Schedules slip, releases fall by the wayside, bugs accrue, money is lost, customers are lost. At this point, your problem, because you've waited so long and accrued so much debt, is one of the hardest problems in your organization to solve. The staff that you have to solve it with is least knowledgeable about the problem domain because everyone involved had moved on. They're the least available because the people that can do the job are busy doing other things, and or the most burned out because at this point you've already gone through possibly years of actually dealing with the ramifications of that technical debt day by day. And that's when management notices. That is when the pain becomes big enough and real enough and, shall we say, business-centric enough that upper management takes notice and actually starts to act. And this is, as you might think, too late. So, how do we deal with that? Well, I have two options to put on the table. Option one is this. You bring in an external consultant who hopefully has the skills and availability and willingness, and because they're external and they're consultants, ego generally doesn't enter into it because there's no longevity within the company. And you take a large stack of cash, you put it in a suitcase, you take the suitcase, you put it on the table in front of the consultant, you slowly rotated it to face them, and you open it so that the gleam of cash confuses them into agreeing to take the project on. You could do that, and it does work. And I've been making really good money paying off other people's technical debt over the last few years. But of course I'm being facetious, because as much as this is a plug, my hope is that you come out of this conversation with some real strategy for not reaching the point where you have to pay me or someone like me ridiculous amounts of money to solve your problem for you. So what's the alternative? What can you do? Well, I call this a management realignment. Let's start by looking at the problem from the organizational perspective, right? We have a problem that we've just gone over in quite a bit of detail, which we need to solve, which is very hard to solve with the people we have and is very expensive to solve with the people we don't have. So, what makes the problem so difficult to solve? Can we do something about it? So if the problem requires people that are extremely skilled to solve, can we somehow reduce the complexity of the problem so we don't need people quite as skilled to be able to manage it? If solving the problem requires a large amount of organizational clout, can we maybe artificially generate that clout? Can we find some way for the people that are tasked with dealing with the problem to have that clout however we reach that point? Same thing with availability. We need people who are available. Can we artificially generate that? And if we need people who are egoless, and those people, as you know, don't really exist, or at least are very, very rare, can we find a way to satisfy egos so that people are willing to take this work on? Now, although the answer is yes, it is not easy, right? There are some things we can do to actually address this within the organization over time. But it does require a substantial investment and some changes in how we structure the organization and perceive technical debt as a strategic thing to manage within the organization. What do I mean by that? I want to introduce you to a conceptual new job function, right? We have back-end engineers, we have front-end engineers, we have ex-engineers, we have SREs, we have ops people, we have business people, we have management. We have all these different functions within the organization. And my spiel, my pitch, is you should consider a new function within the organization, a function I like to call the tech debt collector, right? By definition, an engineering staff, not dissimilar to any other engineering staff, whether it's backend or SREs or what have you. And there are certain skills required of the people that would be able to manage technical debt for the organization. So one skill is they need to be very good at archaeology. That is to say, they need to be able to take a pre-existing complicated system and be able to dig into the code, into the documentation, into the scripting, into the metrics, into the alert stack, into everything that the organization has around these systems, and start to figure out what the system is, how it's constructed, why the decisions were made the way they were, and connecting the dots so that you can actually form a coherent plan on managing or dealing with any particular piece of technical debt. Pardon. These people also need to be relatively fearless. There is a lot of perceived risk associated with dealing with technical debt, as with any migration project. Think schema migration. You want to change a schema, everyone panics. It's risky. Hopefully we're beyond that as an industry, especially in the Java space, but still, you kind of have to have that mode of thinking that says, it doesn't matter how risky it is, it matters how I manage the risk. There's a certain amount of fearlessness required. Tenacity is the other side of that coin. You need people who are stubborn, who will not take no for an answer, who will follow a problem to its very conclusion, regardless of how annoying or esoteric or unglamorous it is. And the last thing is you need people with large prefrontal cortexes, which is a very, very, very silly way of saying the people that you put in charge of technical debt have to be able to keep a large amount of state in their head at any one time. And that is not a skill everyone has in the industry or anywhere else. And the reason why it's so critical here is because to make sense of technical debt and to make sense of a large, complex, highly integrated system within your organization and planning for some kind of migration process, you need to be able to keep a lot of disparate pieces of the same picture in your head. This is a skill. It can be evolved. Some people are better at it, some people are not. But I have found that the people that can actually break down technical debt into a coherent plan for dealing with it tend to be able to keep a lot of details in their head at any one time. Now, you might know some people like this. We already have engineering functions that kind of have roughly the same set of required skills. So solution or architect engineers is a surprising example of that. These are the people that we all know in some way, shape, or form, but these are the people AWS sends to prospective AWS customers to sell them on AWS technologies. Right? So the skill set, by definition, is you come up to a customer you've never met before and you don't know much about their system, their setup, their tech stack, their people, their organizational structure, and you have to start learning about it. Right? You have to figure out what the customer wants so that you can upsell them on Aurora or whatever it is that you're trying to sell at any one point. So there's a lot of overlap in that form of archaeology and reasoning that solution engineers tend to need to do. Other examples are backend developers. Backend developers tend to be focused on the sort of problems that are sort of more invisible, but also larger in integration scope. Right? There's more moving parts in the backend as compared to the front end. That is a gross generalization, and it's not super important. So if you want to argue about that, I will concede the point. Right? My point is, we already have people with those skills. We just put them elsewhere. So, assuming you have those people or can hire those people, what remains for us to actually have a strategy whereby we as an organization don't reach the point where we are panicking and breaking? What does it take other than people? There's a few leading questions I would like to pose and answer. Don't worry, this is not an audience participation bit. Who owns technical debt? Right? There has to be someone within the organization that owns technical debt in the same way that there's someone in the organization owning financial debt or owning the delivery timetable or owning the product, right? The product decisions. There's always ownership. Who owns technical debt? That's one question to consider. The other question is, who can prioritize technical debt? Because there's always going to be technical debt. There's always going to be some nasty leftover things, and not all technical debt is made equal. Both in the sense of not every piece of technical debt is as hard to manage as the next piece, but also not every piece is as damaging or important. Next, who decides on hiring and compensation? If we want to have a specialized type of engineer for dealing with these types of projects, who can make the decision on hiring them? Who can make the decision on how much we pay them? And finally, who can lend organizational clout? Right? We've hired these people, we've figured out a compensation structure, we've prioritized their tech debt, this is all owned within the correct part of the organization, but we still need that organizational clout so that the people charged with dealing with these types of projects can actually approach other teams within the organization and either get or coerce their collaboration so that technical debt can be dealt with over time. And in all cases, I would argue the answer is upper management, upper engineering management. Now, whether it's the CTO or the VP R&D really kind of depends on your corporate structure, and it doesn't really matter. What's important is if you look at every one of these questions, the answer is VP R&D. And here's why. Because at the point where the organization starts to panic and wants to do something about the technical debt, the people that panic first are the business people, because obviously there's business risk, otherwise we wouldn't be having this conversation. And the people who feel the pain the most are the people charged with delivery, which is upper R&D management, typically. Right? They're also the people that own the budget and can make decisions about hiring and compensation. They're also the people best placed to proxy the customer because they are the customer, right? They feel the pain. And they're best placed to say, I don't care what you think. I don't care about your priorities, dear Team B. Team A is now running the show on this technical debt payment project. You will give them what they need, right? The people who can make that determination are the upper management folk in R&D. So, you might wonder, can this really work? And the answer to that is obviously opinionated, but I think so. I've never seen an organization try this out as a strategy. I've never seen this fail either, right? So can this work? I think so because, again, as an independent consultant, I'm being paid very well to provide that service because the companies that pay me well to provide that service have never put together a strategy and an organizational plan around technical debt. They call me in when things really hit the fan. With that in mind, takeaways. Technical debt is inevitable. It's a fact of life. We all have it. We all will continue to have it for as long as we're alive. Why? Because it's a tool. It is not inherently a bad thing. Having technical debt is not the problem. Having unmanaged, out of control technical debt is a huge problem, which means debt management is critical. Some might even say crucial to the survival over time of your organization. If you want to avoid catastrophe, you need to manage your technical debt. Same as any other debt, certainly financial debt. It also means that paying that debt requires dedicated personnel, because you need people who are, as you might recall, skilled, highly available, egoless, and available, which means you need a strategy. You need to manage this. You need to plan this. If you don't, you're going to end up paying someone like me and hoping for the best, right? I'm not saying what I put out here is the right solution for it, because I don't know what the right solution for it necessarily is for the whole of the industry. What I can pretty confidently say is I don't know any organization that has technical debt management as a first-class strategy within how they run R&D, and they all end up in the same place of freaking out when the technical debt gets out of control. Some of them manage to survive that mess, some of them do not. But even the ones that do survive the mess typically end up in the same spot 3, 5, 10 years afterwards with new technical debt that they've failed to manage. So managing technical debt is paramount, in my opinion. And with that, if there are any questions, I'll be happy to take them. I'll switch to Slido in a minute. Both me and the conference would absolutely love feedback, arguments, points, anything you can say about the talk, about the subject matter, about the conference. Please go ahead and scan the QR code and provide any feedback you may have. Let us switch over to questions if there are any, and then I will happily bid you adieu. One question: how do we distinguish between technical debt, which is a strategic choice, and a skill gap, which is a lack of capability? I'm not sure we need to. Skill gap can cause technical debt, but those are two completely different things. Right? You start with a decision. The decision doesn't have to be bad for it to accrue technical debt. In fact, technical debt, assuming technical debt might be part of the decision-making process. Shitty decisions tend to involve creating more technical debt than non-shitty decisions. And a skill gap can cause you to make shitty decisions. But then your problem isn't technical debt, your problem is making shitty decisions. So those are two kind of different parts of the life cycle of the decision-making process, if you will. I hope that makes sense. Do you think that using dedicated personnel to pay down tech debt perpetuates the incentive for everyone else to keep producing more of it? I don't think so, because if you recall, the people that feel the technical debt first and most are us, right? We all suffer because of technical debt in some way, shape, or form. And none of us generally are incentivized to deal with it. So if you run across having to integrate with a system that's either broken or has a shitty API or fails all the time, or if you have flaky tests, whatever it is, you're feeling the pain, but you're never in a position to deal with it because you're always chasing some other deliverable, and management tells you very clearly, no, we don't care about that stuff, just get this done, right? So by definition, you're feeling the pain and you're not allowed to do anything about it. I don't think adding people that manage that technical debt, quote unquote, for you, it's not even for you, it's around you. I think the end result of that won't be that people create more tech debt, it's that people will be happier because they don't have to deal with as much of it. I could be wrong, but I don't see how that becomes a real problem. Next question: why organizations do not manage technical debt? I have hopefully covered it, but the TLDR version is because A, it's really, really hard, and B, the pain that upper management feels only comes at the point where the technical debt is already a huge problem, right? It's an incentive issue. If as an R&D manager, I don't live that pain, I don't deal with the flake tests or whatever it is that's causing the pain, I'm not incentivized to manage it, right? This has to change in some way, shape, or form for me to actually want to put the resources on dealing with that. How do you solve technical debt when you get hired? Must take years. I'm assuming the question means me personally as a consultant. There is no one answer to that. It really depends on the organization that hires me, their maturity level, what kind of technical debt they have, and how spread around it is. So in that case, vertical technical debt, by which I mean a system that is old enough to be feeling the pain from having been run long enough and having sufficient scale, but is not necessarily all that integrated, those tend to be easier. The horizontal technical debt, the integration efforts, the ancient telemetry system that no one understands and we want to replace with open telemetry, whatever the project is, can take years, and it can take weeks, and it can take months, and it all depends on the project and how the organization chooses to manage it. It's not always successful either. So I've been in a position of saying no to projects because I feel that the organization that's trying to hire me doesn't really have an internalized understanding of what their pain is, and therefore I don't think I can necessarily help them get to the point where that pain is fully understood and solved. But there is no one answer to this. With some customers, it takes weeks. With others, as you said, it takes years. It all depends. How do you force the CTO to acknowledge that technical debt is not the fault of the current system owner and to provide support instead of reprehension? I would argue that's hardly ever the problem, because at the point where the CTO becomes involved in the conversation, the person in charge of that original system is long gone, and the people that are keeping the lights on that system were never part of its inception and original design anyway. So finger pointing doesn't really do anything. You don't really have anyone to finger point to, because even if they're still members of the organization, generally they will have moved on long ago. It's like, sure, you can blame someone for a decision they made 5 years ago. That's just not going to lead anywhere productive in any way, shape, or form. So I don't really try to convince CTOs not to do that. If they approach me, usually at this point they're well beyond finger pointing. They have a problem they need to solve. I would say even if they haven't approached me or haven't gotten to the point where they would want to approach someone like me, at this point the problem is so self-evident, no amount of finger pointing is going to change it or is going to solve it. So I get into the conversation at the point where we're well past the politics. It's a very nice situation to be in. I think we're out of time. There are still a few questions. If you do want to ask them, feel free to hit me up after the talk or outside. Thank you very much for your attention. Have a lovely conference. Cheers.